Assalamu alaikum kids. So today we are going to learn about scalars and vectors. All right. Now scalar quantity is simply quantities which only have magnitude. So let's say for example you have mass, distance, time, area, volume, speed, density, so on and so forth. So a lot of more quantities you will eventually learn which do not have any direction as well. Then you have vector quantities. Now vector quantities have both magnitude and direction. All right. So quantities that have magnitude and direction, example, you have velocity, displacement, force, acceleration. All right. Now you have the magnitude 12 and then you have the direction north. You have the magnitude 25 meters, you have the direction down. You have the magnitude 15 newtons, then the direction 30 degrees. All right. Over here, mass 10 kilograms. Again, in which direction? There is no direction to mass. Time 13 seconds. In which direction? Again, time does not have a direction as well. So this right here is a general description of what your scalar and vector quantities are. I repeat, scalar quantities, only magnitude, no direction, vector quantities, both magnitude and direction. I hope that made sense. Adding scalar and vector quantities is a little different. Adding scalar quantities, all you do is you add their magnitudes. All right. So let's say, for example, you stand on a scale. All right. You measure your mass. Now you stand on the same scale with a 20 kilogram plate in your hand. What do you think is going to happen? Your mass is just going to be 20 kilograms more. Why? Mass is a scalar quantity. Your mass plus 20 will give you the total mass. So you add both the magnitudes. Further, you have some more examples of mass, distance, and time being added. So 1 plus 2 just gives me 3, 12 plus 20 gives me 32, and 15 plus 11 gives me 26. All right. So this right here is example of adding scalar quantities. Now adding vector quantities is slightly different. First, you need to be able to represent a vector on paper. Now let's say for example, I say that you have a 10 Newton force. A 10 Newton force cannot be made on paper. Force cannot be drawn. All right. So you need a method to be able to draw the 10 Newton force on paper. So we simply do what? We represent a vector by an arrow. All right. So the simple arrow right here will represent your vector quantity. Now, the length of the arrow will represent the magnitude of the vector. So 10 newtons, the 10 will be represented by the length, and the arrowhead will of course give you the direction. The arrowhead side, so this side right here is known as the head. All right. And the opposite side where essentially you start the arrow is known as the tail of the vector. All right. And again, adding the vectors includes three important steps. So number one, you have to scale the vector. Then you have to determine the direction of the vector, and then you use the head to tail rule to add essentially maybe 2, 3, 4, or whatever number of vectors. You add them using the head to tail rule. But before adding them, you have to scale them and you have to determine the direction. All right. So again, we are going to talk about scaling and directions of vector in the upcoming videos. All right. So I'll see you there. Bars out.